Okay, so let's have a look at the halogens. So the halogens are at the sort of opposite side of the periodic table. They're not quite noble gases, so they've got full outer electron shells, so they're in that next group in. So we're dealing with fluorine, chlorine, bromine and iodine. We're not going to deal with the last one, it's too big, we don't care about it. So these are the most sort of common ones. Fluorine's not one that you're going to come across in a school laboratory. It's far too reactive for one thing, and that's just a little bit dangerous. So what do we need to know about the halogens? Well, first of all, these are non-metals. So group 1 were metals, these are non-metals. We need to know what their basic properties are. So as non-metals, they have low boiling points and low melting points. And indeed, 2 of these are actually gases, and bromine's a liquid, but it's pretty volatile. That means it will give off a gas. So you know, their boiling points and melting points are really low down there. We also need to know what their sort of overall appearance is. So fluorine, which I always want to put as Fl, don't know why, is a pale yellow gas. Chlorine is a pale green gas. This reminds me of swimming pools, chlorine. Bromine is a kind of a reddish coloured liquid. And iodine is a kind of almost a greyish black. I'm going to put it down as black solid. So we can see that they're going from gases through liquids to solids as you go down the group. You also need to know that they don't dissolve very well in water, but they do dissolve in hexane. And when you dissolve them in hexane, which is an organic solvent, they again reflect these colours. So fluorine will give a pale yellow solution, and there are photographs of this in your textbook. Chlorine gives a pale green solution. Bromine gives an orange solution. And iodine gives a purple solution. So again, that should be in your sort of general description of your halogens, the general sort of things, and then the 2 that you've picked, whether it be fluorine and chlorine, or chlorine and bromine, or bromine and iodine, you need to say what they look like at 25 degrees centigrade, what they look like if they're then dissolved in hexane. And of course we need some atomic structure, so that will help us to describe and explain our trends. So again, I would do the smaller ones because I don't like drawing atomic structures particularly. So fluorine has got 2 electron shells, and it has 1, 2, 3, 4, 5, 6, 7, and then a sort of a gap, electrons in its outer shell. So that's fluorine. Chlorine has got 3 electron shells, two, then 8. So you can see we're moving down the group, so the atoms themselves are getting bigger. 1, 2, 3, 4, 5, 6, 7. So no surprise, these are in group 7. They've got 7 electrons in their outer shells. Now if you do bromine, you have to be quite careful, because bromine has only 4 electron shells, but it's a bit weird. And again, if you do iodine, you'll have to look it up. So 3, 4. So it's got 2 in that shell, 8 in this shell, just as usual. And then rather strangely, it's got 18 in its outer shell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, let's squeeze them in, 15, 16, 17, 18. And then it's got 7 in its very outermost shell. So you do have to be careful with bromine if that's one of yours that you choose to talk about in your assignment.